Move on. And this is something that I never understood about a statistics curriculum. They want me to cover regression next. However, regression is technically inferential statistics, which requires probability to understand. So why they want me to do it before probability, I will never understand. Plus, it's bivariate. And the test sheet itself. So bivariate, this should actually be one of the last things we cover, but they want me to do it now. So I'm going to do it. All of the data that we've been examining has been what's known as single variate. Single variate data. How realistic is it? Not very. Right? You're doing an experiment. How often during the experiment is there only one factor that contributes to what you're analyzing? Because that's what single variate means. There's only one contributing factor. That never happens. It is always multivariate. In this course, we only go up to two-variate, bivariate. So ordered pair, we should be familiar with that from algebra. Ordered pair consists of values of two variables for each individual in the data set. Normally, you're used to seeing ordered pairs x comma y to represent the coordinates. Data that consists of two pairs is known as bivariate. You have a response variable, which is your dependent variable. This is the variable whose value can be explained by the value of the explanatory variable, or your independent variable. So typically speaking, it's the explanatory variable that's going to change. And your response variable depends on that change. Right, that's why we use dependent and independent. And if you look at graphs, y equals, I'm just going to use a line, y equals x plus 1, right, as a line. Slope 1, y-intercept at 0, 1. In that case, x would be your independent variable. Y depends on the value of x. We visualize bivariate data via scatter plot. Graph shows the relationship between your two quantitative variables on the same axes. Your dependent variable, I'm sorry, not dependent, explanatory. Your independent variable is always the horizontal axis, which makes the response, your dependent, the vertical. And typically what we want to do is examine the relationship between the dependent variable and the independent variable. There are, in theory, an infinite number of relationships. In this course, we only study one in depth, the linear relationship. Here's a scatter plot. Here we'd say there is a positive linear relationship. This is nonlinear, obviously. This one's actually quadratic. This is a quadratic relationship. But for purposes of this course, we're just going to say it's nonlinear. Kind of relationship here. What is it? Negative what? That'd be negative linear. What are we saying?
What's this one right here?
Which one, White Rare?
The one that's not labeled.
That's what I'm asking.
What is it?
Yeah. What kind of relationship do you think? It's not what we would call it. There's no discernible relationship.
They're not going to add that right.
Most definitely not linear. Can you actually identify what that would be, though? I agree it's negative, but negative what?
Negative nonlinear?
What type of nonlinear? In theory, there's an infinite number of nonlinears. Just to see if you're familiar with this. You're not expected to be. This would actually be a negative exponential. Specifically, this is an exponential decay. But again, for our purposes, it's just nonlinear. What do you think? Kind of relationship. Did you say there's a linear relationship? Positive or negative?
Doesn't matter where the dot's located as long as it's going in the general direction.
Like, I see this is also positive, right? But it has 2, and this one has 3. So how you gonna know which one is? How you distinguish between them?
Depends on the data. But that's not important. All we say is that the two variables have a linear relationship.
Positive linear relationship.
Yeah, it's a positive linear in both cases.
So pretty much, if it starts at the left axis,
Doesn't have to start there. As long as the data follows a linear pattern.
Okay, so the negative explain this way from because I'm left this positive starts from the 0 point.
Again, it doesn't have to.
I guess people think they're confused.
You could cut out all this data down here. That's still positive linear.
Oh, okay. Once it's the same.
The one that it really don't have like a curve to it is positive.
It's positive because it's,
Going upward.
yes.
Okay, thank you.
Well, now we want a way to measure the strength of this relationship. And we don't call it a relationship. We call it a correlation. So the linear correlation coefficient is a measure of the strength and direction of the linear relationship between your two variables. Here's another reason why I don't call it. It has a formula. Ready? There's your formula. That is nightmare fuel. We will not be using this formula by hand. We will be relying on technology. A statistics calculator generally can find the linear coefficient. Obviously, you can set up the formula in Excel. Any statistical software like Minitab will do it for you. By the way, there's a typo in the notes. I'll let you find where the typo is. I'll just say, this is the correct formula.
I see it.
What is it? See what the error is? Said you found it? What's the error?
It's the second square root.
Yeah, the notes have it as a nested square root. It's not. That second term in the denominator, they put a square root.
So that's
That
right.
square. This is the correct formula.
Okay, thank you.
So should we just delete this right here?
You can't edit that. Just ignore it. It was just a typo. I just accidentally hit the square root when typing it up. That's why I get paid the big bucks. Because I know these formulas. As soon as I saw that, I said, that ain't right. And just to make sure that I wasn't going crazy, I verified it with 3 other sources. This isn't even really the formula that I use. It's the equivalent form of the formula.
Just like the easier version.
I don't know if easier is the right word, but it's not written as a complex fraction as it is here. You have to forgive statisticians. Either they don't know the rules of math or they don't care about them. But that is taboo in math. That might get you a shanking. Properties. First one is very important. Your coefficient will always be between -1 and +1. Inclusive. Meaning, if you calculate R, and it is not between -1 and +1, you did something wrong.
So always have to be a decimal.
Or it can equal -1 or +1. Right, but it'll never be outside of that. So if you get an R to be like 1.2, you did something wrong. Now, if it's like 1.0002 or something like that, then that's probably just rounding.
Okay.
Right? At which point you probably just say 1. It's probably just a rounding thing.
So do we stop at the third?
Just depends. 1.2 is definitely not a rounding error. Something like 1.002, that's pretty close to 1, so I'd say that's probably just due to rounding. At which point I just say, yeah, my R. I check to make sure everything's right, and I just say, yeah, my R is just 1. R equaling 1 means there's perfect linear correlation. Show of hands. Who thinks that ever actually happens in real life? Good. If you ever get R equals 1, I'm going to assume you fudged your data, which is academic integrity violation. I'll obviously check it to make sure, but that's going to be my first assumption. Because that never happens. Same thing with R being -1. It means it's perfect negative linear correlation, which again, never happens. When I say never, I mean statistically never. The closer R is to 1, the stronger the evidence of positive linear association. See, this is where you need probabilities. Because there is an analysis done on R using confidence intervals that we haven't covered yet. Which means you have to take my word for it that that's true. Closer R is to -1, stronger the evidence for a negative linear association. So if R is 0, what do you think?
I don't think that's.
There wouldn't be any evidence to suggest a linear correlation whatsoever. Right, so the closer you get to 0, the weaker the evidence, specifically speaking. If you're really close to 0, you can't assume that that there's linear correlation. There's probably not. To be fair, even like an R of 0.5 is kind of weak. That'd be very weak linear correlation.
So that would be like 0.9.
0.9 would be very strong. If I go back, these two would be 0. This would not, this probably wouldn't be 0, it'd probably be really close to 0 though. This would probably be like 0.9, 0.8, 0.9. This would probably be like negative 0.8, 0.9. This would probably be like a 0.6 or 0.5, something like that.
So if it was to come out to 1, would just basically like a straight line.
Yeah. Your dots would just be in a straight line, which never happens. Right, you may get a homework problem that it happens on, but that's because the numbers are made up. It's not actual research. Note that this does not mean there is no correlation. It just means the correlation is not linear, as I showed with the two nonlinears. R was 0 there, but they were still correlated, right? Just not linearly. R has no units of measure. It's unitless. Based on what R is representing, we can easily conclude that R is not resistant. Extreme values are going to affect it. Say there's a point here. That's going to affect the correlation coefficient. Now you start to get several points clustered in here. Now it's really affecting your R. Really don't know if it's discussed in this course. That's why, generally speaking, if you have like 1 or 2 outliers, you just throw them out and then do the analysis on the new data set. Because those are just extreme values. Start to have several of them, well, now you can't really throw them out. Caution. Correlation is not the same as causation. Just because there's a linear correlation between X and Y, or not even linear, just because there's a correlation between X and Y does not mean that X causes Y. I go back to the example I used at the start of the semester. There's a correlation between ice cream sales and number of drownings at the beach. Does that mean that selling more ice cream causes more drownings?
No.
No. There are other factors at play, but they are correlated. If you have a correlation, you generally cannot conclude that changing the independent variable will cause for certain a change in the dependent. It's showing that they're associated, not that one causes the other. They could both be caused by some outside third variable. Like the heat gets hotter, the hotter it is, the more sales of ice cream you're going to have, and the more people who go swimming, which increases their chances of drownings. So now here's the question. Go back to the very first one. What's the line that best fits that data? That is called your line of best fit. And there are in general several ways to find it. We only look at one method. Happens to be one of the most common methods. This is made so much easier with linear algebra. It's called least squares regression. The line found using this method is the line in which the sum of the squared vertical distances from the observed value and the line is as small as possible. Hence the name least squares. Regression itself is a term that is used to represent finding a best fit. Right, so that second scatter plot would be quadratic regression. And again, there are several ways in which you can find that. The line found from this method is called the least squares regression line. Or I may just refer to it as the least squares line. Here it is. Y hat is B0 plus B1x. I hate that order. It should be B1x plus B0, but again, mathematical semantics. And again, this is where it gets fun. There's B1. So the slope of your regression line, right? Remember, that's slope-intercept form. Slope of your regression line is your linear correlation coefficient times the standard deviation of y over the standard deviation of x. That's just terrible. That means you got to find three horrible statistics. You got to find the linear correlation coefficient, which is nightmare-inducing in of its own. Then you have to find two sample standard deviations. And you just had a test on all that. Here Remember how hideous that formula was. So that's 3 nightmare formulas just to find the slope. So I'll say that in another way. It's R times the standard deviation of your dependent variable, your response variable, divided by the standard deviation of your explanatory variable, your independent variable. Because while typically, yes, we will use Y to represent dependent and X to represent independent, that is not a rule. It's just a convention. In fact, in my main field of interest, T is usually the independent. B naught is a little bit nicer, except it requires you to find B1 first. It's Y bar. What does that represent? What did Y bar mean? Uh-oh. Again, they're just tested on this.
The residual?
No. I didn't even cover residuals yet.
Oh, the intercept?
I'm looking forward to grading these. Sample mean. It's the average of Y. So it'd be the average of your response variable minus your slope, which is that nightmare formula, times the average of your explanatory. Once again, we will not be actually doing that by hand. Slope tells us on average how the response variable changes for every 1 unit increase in the explanatory. Now, this is where you want to be careful. Again, in fact, this is always true. The least squares line represents a model. How did you determine that model? From observations, specifically the observations of X and Y. So would it be a good idea to use that model for some value that would be considered outlier case? All right, so let's say we did a model for temperature. What's the temperature on Earth? What does it range from?
98 something.
Negative. Actually, that's a good idea. How low does it go? Negative 25 centigrade to 45 centigrade. Yes, I don't use that evil empirical system. Fahrenheit is part of the evil empirical system. Use it.
I like Fahrenheit.
Technically speaking, centigrade also isn't proper. Should be using Kelvin. Why is Kelvin better? So glad you asked. What does 0 Celsius represent?
Nothing?
Zero.
Freezing point of water. Not lack of heat. 0 Kelvin means no heat. It is absolute 0.
How can your teacher say heat is non-existent? Heat is non-existent. Like,
That's just a lie. Cold is non-existent. Heat is what exists. Cold just means lack of heat.
So if it's negative, like, if it's negative 5 below Celsius,
That's 5 degrees centigrade below freezing point of water, which is tolerable. In fact, I worked in industrial freezers that were negative 40 Fahrenheit.
so when you say negative, so there isn't like a negative Fahrenheit then?
There is. Negative 40 Fahrenheit does exist. What's the freezing point of water in Fahrenheit? 32. Which means 0 Fahrenheit is below freezing, so it'd be below 0 Celsius. Negative Fahrenheit does exist. There is no negative Kelvin. Kelvin would go, for our typical scale, freezing point of water to boiling point of water, 273 to 373 Kelvin. 273 Kelvin is the freezing point of water, 373 is its boiling point. Fahrenheit is just equal. Right, so okay, so negative 25 Celsius to 45 Celsius would be the average temperature on Earth. So let's say we came up with our temperature model using that temperature range. Should I use that model for 100 Celsius?
no.
No. That is way outside the parameters of the model. And again, this is always true. Whenever you come up with a model from observed data, you should never use it as a prediction for a data point that is well outside your parameters. That is how people die. So that's what this is saying. There is a way to do it called extrapolation. But that is certainly outside the scope of this course. That would be more like a level 300 course. And generally speaking, it involves coding.
So we don't have to worry about extrapolation.
We won't be using extrapolation. To my knowledge, I haven't looked at all the notes. But extrapolation is generally a very tough process that requires the use of a computer language. I've done extrapolations. It was my junior, well, technically I wasn't junior math because I picked up the math major after, but it was a junior level math course. So level 300. And it did require coding. Residual analysis. Again, this is true whenever you model. Whenever you model, there's always error. jump on a scale. Well, don't actually literally jump on, but go on a scale. Read its weight. Is that your actual weight?
So,
If you go on a scale to get your weight, is that your actual weight?
So if you go to BMI one, probably.
well, you're gonna be maybe over.
How is BMI measured?
That's fine.
I see what you're saying. Like how technically how is it?
The weight on the scale is not going to be your actual weight
That's that. That's the one.
for a few reasons. One, how many decimal points does the scale typically go out to? 1. But right there, you don't have good precision. Also, there could be error within the actual machine itself. Right? That's where, if you listen to polls and they talk about margin of error, that's what that means. So I don't know what would the scale be. Let's say the margin of error for a scale is 1 pound. That means you could be up to 1 pound over or up to 1 pound less than what the scale's reading, because there's error associated with it. Now, let's say it's not one of the digital ones. It's one of the ones that you actually have to read yourself. Well, now there's error associated with your reading of the scale.
Like the tip there.
Are you accurately going to read it? Chances are you're not. So now you have an error of reading what it's giving you, which also has error. So now you have error on top of error. There is always error associated. That's essentially what residual analysis is. It's an error analysis. Given a point on a scatter plot and given the least squares regression line, the residual for a point is the difference between the observed value and the predicted value. It is your error of the model for that point.
Let's see, analysis. So this analysis shows that there will always be an error.
The analysis itself doesn't show. The analysis is analyzing that error.
Oh, analyzing the error. That is assuming there is an error already.
You don't need to assume it. That's going to be a given. It is given. There will be error.
There will be error.
Whenever you model, there is error.
There is error. So you're going to be analyzing this error.
The residual analysis is error analysis. We're analyzing the error
The
itself.
errors. Okay.
Whenever you do an approximation, so again, it doesn't apply to this course, but in a lot of applied math, you have to do approximations because there's no exact values. There's error associated with approximation. It's generally error analysis that'll tell you how large you want your sample to be within a certain margin of error. That's called error analysis. Again, the error analysis itself is well beyond the scope of a standard freshman level course. This type of error isn't that terrible. The residual plot, well, big surprise. It's a scatter plot of the residuals. The residuals are plotted against the values of the explanatory. When the residual exhibits a noticeable pattern, there is no linear relationship. Meaning, do not use the least squares line. If there is no noticeable pattern, there might be linear correlation. might be. You can't say for certain that there is.
Error or not?
Well, the residual plot is essentially a plot of error.
Oh, so.
This is one of the things that gets confused a lot when you first start your journey in science and research. You can't ever prove anything in science. Gravity. So, that's the example I can use. Climb up the Empire State Building and jump off, what's going to happen?
You're gonna hit the ground. Depending on how high you're going.
You're going to fall, right? Is gravity actually proven?
Yes.
It's still just a theory.
Yeah.
We don't actually know that that's how gravity
Yeah.
works. We call it a law because we haven't found any evidence so far to contradict it. In order to be true, that model of gravity would have to be true in every possible circumstance. Have we tested every possible circumstance? Have you stood on the surface of the sun and tested it?
That's different.
How's it different? We're still modeling gravity. Have you gone to a planet in the Andromeda galaxy and tested it?
I see what you're saying now. In order for something to be proven fact, it has to be tested not only on Earth.
It has to be true for every circumstance. Every possible circumstance. There's only one field in which you can actually prove something, and that's math. And even then, it's iffy. Math is not a complete subject because we're taking a certain set of axioms to be true and they can't be proven. We just assume they're true. So that is why we never say, this is known for a fact. We always say, might be. Or there's strong evidence to suggest. Right? So I wouldn't say, if you jump off the Empire State Building, you're going to fall and splat on the ground. I'm going to say, there's very strong evidence to suggest you're going to become a splat on the sidewalk.
So basically, you're saying 1 plus 1 might be 2, but it's not proven. It should be 2.
Depends on how we define addition, how we define 1, how we define equals, how we define 2. And then there are certain axioms. And in fact, I can change the number system and say 1 plus 1 is 0. Mod 2. 1 plus 1 is 0 in mod 2.
1 plus 1 is 0.
In mod 2.
I got confusion.
Yeah, this is why I love math. Math is awesome. Not as awesome as physics. So remember that an outlier has a, oh, this is for residual. So remember what outliers are? An outlier has a standard residual that is either greater than 2 or less than negative 2. Influential point is a point that would strongly affect the position of the least squares line. If I put a point here, it's not influential. If I put a point way down here, that's influential.
So if it's on the right side, it is.
No, it's just, even if I go up here, it'd be influential. But if I put a point that's relatively close to this scattering,
Okay.
it's not really going to affect your line that much. But now you start to get really far away, now it's really going to affect that line, right? If I put one up here, the line's going to want to try to include that point. So it's probably going to try and go up like this or something. That's just going to greatly affect it. Or the line may even shift up, maybe like this, but it's going to greatly affect the positioning of the line. Coefficient of determination is r squared. Measures the proportion of total variation in the response variable that is explained by the least squares regression line. So it's that squared. Which makes it somewhat better. Because at least we got rid of the square root. But still, it's a horrible formula. R squared will always be between 0 and 1 inclusive. So again, get an R squared. That is not in there. Generally speaking, for things like this, like R and R squared, I don't give partial credit if they're outside the known range. So if you give me an R of 2, I'm not going to give you partial credit. I'm going to mark the whole thing wrong, because you should know that you did something wrong. You get an R squared, that's -8. I'm really going to be sad. For 2 reasons. 1, it's not between 0 and 1. And 2, you're telling me a squared is negative. Which is not possible for this class. Yes, you can have a negative square. That requires moving to the complex plane.
So it has to be between 0 and 1.
R squared will always be between 0 and 1 inclusive.
Okay.
R squared being 0 means the least squares regression line is useless. R squared equals 1 means it explains 100% of the variation, which again, never happens. Disposition's out of the way. Now we can actually get to do some data analysis. 30 high school students were surveyed in a study involving time spent on the internet and their grade point average. Results are shown. Create a scatter plot of this data and find the line of best fit. Show you using both Excel and Minitab. As you can see, I already have the data saved, so I'm gonna have to spend half an hour just re-entering it. So first thing you want to do, insert your data. Scatter plot. You just go to graph, scatter plot. We just want simple. I could do with regression, but for now, just simple. Now you need to determine what is your y variable, what is your x variable. So what is the explanatory variable here? Hours. The response variable would be GPA.
So hours would be on the side, right?
Hours is x.
Yeah.
That's your horizontal. Hit OK, and there's your scatter plot. And by the way, many tab labels are wrong.
What you mean?
Notice what the title of the plot is. That's incorrect. Horizontal versus vertical. It is always explanatory versus response.
So I didn't get that. Which one is the introductory?
Explanatory is always horizontal.
That's the hours?
The response is always the vertical.
So I'm trying to distinguish.
So it should be hours spent on the internet versus GPA.
Okay.
And then so you go to where you go? Once you enter the data,
Oh wait, can I change this? Yeah, no, it didn't change that though. It changed this up here, but not this. Why is it not letting me edit? It won't let me actually change the title. That's annoying.
Yeah. You got a face that you already know, right?
Is that what I think?
so you go to insert.
Graph, scatter plot,
Hours.
and then just do the simple. To find the line of best fit, I'm actually going to try scatter plot with regression. Let's see what that gives me. Y would be GPA, X would be hours. So there's a scatter plot with the regression line using that method. The method I actually used, stat, regression, fitted line plot. Response, GPA, predictor, hours, okay. All right, notice it's also going to give you this stuff here. The advantage to doing it that way is it actually gives you the equation of the regression line. Whereas notice that method didn't.
Okay, can you just please go back and let's get the process of that. Can you please just redo that so we see the process of
It's stat,
yeah, what you use.
regression, fitted line plot.
Fill that out.
Then you're going to have to enter your dependent and independent, and then just hit OK.
Okay.
Oh, and choose the type of model, but just stick with linear.
So response is always dependent, right?
Response is dependent. Yes.
You don't have a graph button for the Mac.
Hmm?
You don't have a graph button.
I should.
No, right? It's crazy.
There's one more reason why I shouldn't have a Mac.
Oh, my goodness.
You know what Macs are actually intended for, right? Programs.
Yeah.
That's all it's intended for. That's all it's good for is coding. Trust me, as much as I have beef with Microsoft, they are the superior computer
It
for
was
most
first.
everything.
It was first, so
Pains me to say that too. Because I do not like Microsoft as a company. Now let's do this. So you can't see my behind the scenes. Now if I change, yes, you will not see this. Okay. So Excel. I'm going to enter my data. Ready? That was easy. Wizard typing in data. Insert. This one right here. Oh, it's not just. So let's move you up here. Because it's not showing you the drop-down menu. That's the one you want.
Okay.
that's cool.
Right, and that's just, you can adjust things. Right, so what I would do, and I do recommend what you do is you come up to add chart element, axis titles, and add both of them. Primary horizontal and primary vertical. So that you can then put in a title. Hours on the internet versus GPA. And then let's adjust. Actually, you can just double check something. it is supposed to be y versus x. That is not how I did it in physics. I've also read that it really doesn't matter. So how about we stick with? I don't care how you label it. I understand their reasoning. I just don't agree with it.
So I have a question. Maybe I might be right, but in this one, do you determine if it is positive? How do you determine if it is positive, linear, negative, or that's not it?
Just from the plot itself.
Yeah.
So first, look at it. Does it look like it's linear?
Yeah,
Yes. Right, because it seems like all of your points
it's negative.
are kind of in a line, right?
Yeah.
Then it's just a matter of, is the slope positive or negative? Well, it's going down, right?
Yeah.
Negative.
That's how you do it.
So it was during this was like,
Yeah, if it was going up,
yeah.
as read from left to right, because remember that's how we read graphs,
Yeah.
left to right,
Yeah.
then it'd be positive.
So we need to know the difference between a nonlinear. So nonlinear, negative, linear, they all the same basically,
No.
right?
Negative linear, positive linear means that there's a linear relationship, it's just how are they related. Right? Negative means the further along the horizontal you get, the further down the vertical you get. Right? So in this case, a negative relation means the more hours you spend on the internet, the lower your GPA.
Is this like a real study?
I would assume so. I mean, if it's not, I'm pretty sure the publisher could get sued because the book I got this from said it was a study. They may have even cited the study, I don't remember. I never actually read the citation of questions. Because generally speaking, I don't care where the data came from. I'm a mathematician. All I care about is analyzing, and I don't care where it came from. Now for the trend line. This is really easy. I think we're going to need to do this again. Chart design. Add chart element. Trend line. Linear. If you double click on the line, you notice this comes up. So here you can change the type. What I'm interested in is if you come all the way down, second from the bottom, display equation on chart. Click it. There's your equation. Which would allow me to, now if I click that equation, I can move it to somewhere that's legible. It's not necessary to have the equation on there. Especially not for this problem. Because it's just asking for the trend line. You don't need it. You don't need the equation. But if you need the equation, that's how you do it.
You should go to chart. You go to add.
Chart design. Add chart element. Trend line. And then you choose the linear one. Just click it once. I'm gonna put it on.
If it wasn't linear, you would put it at the limit.
You won't have to worry about that for this course, but yes. Like if I wanted exponential, I'd use the exponential.
Whatever you want, you're gonna select.
Yes. So for this course, linear is all you care about. I'll save the others for a more advanced course. Maybe stat 2, if you have to take stat 2.
I hope not.
I never did it either.
Many of you are nursing majors in here.
I think all of us are.
I promise you, you're going to take a more advanced stat course.
We have to.
No, I
Yeah,
thought this
promise
was just
you.
that
I thought
one.
we
Who
just
said
said
that?
it is.
Yeah, it's just that one.
I think it's just one.
One.
It's
That's the
just
only
one.
type course we have to do.
Here, when you transfer, I
Oh.
promise you, you're going to take a more advanced stat course.
When you transfer, that is when you
At
transfer.
a different school, yeah.
Oh,
When you actually transfer to get your bachelor's, I can promise you're going to have to take a level 300 stat course.
Oh my god.
You may even have to take a research course, a research operations course.
Who come up with these curriculums? Like, I
I
don't
know,
understand. Like, why is it so? I
That's
get
too
it,
much
but I
of-
don't.
That's okay. It's a $1 per nanosecond late fee. I just bankrupted you and your entire living and your entire family line.
She said, what's that $1 per microwave?
$1 per nanosecond. How many nanoseconds are in a second?
How many nanoseconds are in the second?
1 billion.
That's how Jeff Bezos did pay.
I didn't even know that.
Because I work with nanoseconds.
I didn't know that.
Picosecond is, I think, 10 to the minus 12.
I didn't know they have something 11 seconds.
That's all we need, right? Yes. That is all I need for this. That's okay, there's also going to be a fee for that. So I bankrupted your entire family, but made my entire family rich. So I'll make sure that transfers to different generations.
And
Of course the test was easy.
Who said that?
no, it's not.
Who said that? Don't be, no.
They blow your mind. You do something as impossible, bring something else.
I know what you're talking about. I got 100.
You got 100 on this. You know what's crazy too? What you did with this thing, this dumb plot? Because when we did it, we went over the 2 digits. We didn't go over 3 digits, so you threw me in the loop there. And I'm sitting here
We
like,
did
I
3
don't-
digits.
With that,
We did 3 digits.
I don't remember doing 3 digits. I had it out of my notes.
We did 3 digits.
I was just sitting here like, damn. I mean, I did it out.
but you at least.
That is given below. Find the least squares line using x as the dependent and x as the independent. So x being the independent is the way that you usually think of it. We also want to do as x as the dependent as well. So we go both ways. And I'm going to use the formulas, not the graph itself. But again, I won't be doing it by hand. I'll be typing it into Excel to show you how to do that.
Do you have 2x object? X as the dependent.
So we're going to do a line where x is your dependent variable, which would mean y is independent. And then we'll do another line where the x is your independent variable, and y is your and y will then be your dependent. So we're going to do it both ways. Because again, remember I said there's no rule that says x has to be the independent.
Okay, okay.
That's just
Oh, so you
conventional.
can, yeah, okay.
So it's essentially you want to measure y against x. How does y respond to x, and also how does x respond to y? You want to do both ways. Which way did I do first? I did the independent first. Maybe I should have done the dependent first. Okay. So first thing you want to do is enter your data. Look how easy that was. Already entered. And you know what? Let me zoom in, make it a little bit. So remember for the formula, we're going to need sum of x and sum of y. I'm going to find that right now. Equals sum. Two ways you can do it. Click and drag. Notice it highlights your data. Good, that didn't show up because it opened up my start menu. Or just type in the cells. A2 is your first cell, colon down to your last cell, A9. And you'll see a highlight. But again, or remember I showed you can also just label your data collection. You can give that data collection like a name. You can also do it that way. Close out your parentheses, tab, enter, something to move to a different cell.
Can you please go over the process again?
It's right up at the top.
And,
Equals sum, then enter your data. A2 colon A9.
like the process of getting the A, the 9, how you have it, that's,
A is the column
yeah.
and row. So the cell A2 would be column A, row 2, which is 1. That's what those refer to. I could do that again for the Y. I could also just click here, drag, boom.
Oh, once it's already set up, you do it like
Right, now notice, see, now if I click on it, see how it's now sum B2 to B9? It copies the formula for the next column. So you don't have to type it in every single time, it's the same. And I'm also going to bold them just so I know that they're not part of my data.
How did you skip the? How did you create the X and Y?
What do you mean?
Cause I keep trying to click A to make it X, Y, but I just have to do 1, 3, 4, 5. For the X, Y, for on the one column. You see what I'm saying?
I like it that one.
You put it on line 1, so like, yeah, if you put on line 1 and then send everything else down, it will look the same.
So I just hit enter at each time. Like if I enter, it'll go down to the next line and I type in the next value for X.
And then they give you the sum.
That's what we just found.
Yeah, so that's how you get the sum, right?
Yeah,
By just-
using Excel. The formula also wants sum of X times Y. So let's create the X times Y column so we can find its sum. Equals A2 times B2. Enter.
So the next one should be fine.
And again, I don't want to enter it every single time. So right that bottom right corner, click, drag, release.
So it's technically like you're adding, you times.
Not adding, multiplying.
Multiply.
I'm multiplying the X and the Y values.
Cross. Okay.
Okay, makes sense.
And again, we're going to want that sum.
2,000.
I didn't understand that part of it. It was just so fast.
We're also going to need a sum of x squareds. So I'll create a column for x squared. All right, so equals A2, caret squared. Caret 2, enter. And again, then just drag and drop. Find its sum. Now I think I can then do this. Because we also want a sum of y squareds. I should be able just to do this. I'll drag that over. Yeah, now it's b2 squared. Perfect. And then I can drag and drop.
So when we're doing like the exam for this for you, we're gonna have to multiply like each one.
I'm not going to make you do a formula by hand.
Oh, okay.
I might give you the chart. Or I might give you like the R value and then say, here's the R value, find the equation. Right, so you're not going to have to actually do it by hand. What I'll most likely do is give you this chart and then you just have to plug in the appropriate values, plug them into the formula itself.
Okay.
Right, so you're not going to have to actually find the sum of all your x squares. I'll provide that for you. And that is all we need. Okay, now comes the fun part. Come down here. We're going to need R, the linear coefficient. Okay, what was its formula? It's the sum of x times y, right? Plus, right? I actually don't recall it off the top of my head. And this doesn't tell me what the formula is. I should consider that. That's okay, because I will go back. Write it.
Yeah, whatever.
X, y. It's not plus, it's minus. Sum x times sum y all over n.
And
And that whole thing is over the square root.
I took a picture.
Sum of x squared minus sum of x squared and y equals minus sum of y squared minus y's squared all over n.
that's a long formula.
You tell me. All right, so sum of xy minus sum of x times sum of y divided by n, which is the number of data points. How many are there?
Oh,
So you want
All
Eight.
of that is one?
you talking about this one, right?
yeah,
Oh,
it,
okay.
That's the numerator.
yeah, it's
That whole thing is divided by square root. SQRT. Parentheses. Square root of into quantities.
That's how we're gonna input that in Excel.
You need
So
double,
that,
double parentheses?
Yeah, because the first parentheses telling me I'm taking the square root of whatever I'm going to put in. This next parenthesis, because it's one quantity going to be times another quantity. Sum of x squared, which was that, right? Minus the sum of x squared divided by n times sum of y squared minus sum of y's squared over n.
Wait,
Enter. I can just go right back up. It's up at the top.
oh, top.
where is it? Oh, on that.
That's not what I got.
That's the wrong answer.
Yeah, we will get there.
You just put enter.
And then you just enter tab. And unfortunately, it doesn't show me what this formula is. On here.
No, I got 0 point. I got that one. But you just put. That's why.
Yeah, which means I may have just made a mistake on my answer sheet. Formula. It doesn't tell me what the formula is on here. So I may have just typed it in wrong in here. Because all my sums are correct. Everything there is correct. Which means the problem is whatever I typed in here.
The only thing is, I can't see. I don't have the visual representation of the formulas up there.
I
don't have
know.
that.
On your end.
Yes, I'll show you. I just did everything.
I think it's because you're using the web version. There's an option to hide it. You may have to actually click the option to show it.
Please.
But I don't know where it is right now. So I'll just take a look. I'm just going to say that's the right one. Because I definitely typed it in right. E11 is x squareds. F11 is y squareds. A11 is sum of x and then square that. Only
What form? What is this? Is to get R?
yeah. The only thing I'm even trying is this shouldn't matter. I'm just trying it. That's right. Oh, now I think about it, I do remember getting an error, and I didn't read the error, and I just did okay. I think it changed the formula. Yeah, that's probably what happened. We also need standard deviation for x. Remember how to find that? Equals stdev dot s for sample for the x. Standard deviations for the y's. Average for the x. average, vendor data,
Here's a high prices.
and then average for Y. I didn't do this by hand. Boom. So cool little feature. If I highlight 2 cells, or even more than 2 cells, come up here, it says merge and center. Just click that, it now merges those 2 cells together as one, which is very useful for titling. So I'm going to call this X dependent. We need the slope and we need the intercept. Right? B0 and B1. What was the formula for slope? B1.
You want to add S Y.
Be careful. SY over SX, that was where X was independent. Right. We're doing X is dependent. So R times
That's why.
dependent SX. Right. Remember, the formula is assuming Y is your dependent variable.
So XY is where D is at.
Huh?
XY is D.
SX is
Oh,
is D16.
okay.
D15 is R. Right. It's also color coded. See the blue text D15, and see how this is blue highlight. That's how you can. It does reference it for you. And then divided by SY. Because remember, it's standard deviation of the dependent divided by standard deviation of the independent. In this case, we're treating X as dependent, Y is independent, which is why it's SX over SY. Enter. Slope is 1.5. And how do you find the intercept? Which is B0.
B, 0, bar Y minus 2.
However, that is if Y was dependent. It's average of the dependent, in this case, X, minus slope times average of the independent. There's your line.
0.5.
That's the intercept. So the line would be X hat equals, see, I always write it 1.5X minus 0.5. Well, I'm sorry, not X, it would be Y.
This is wow. This is just one question.
Yeah.
That's what I'm saying.
And again, imagine if you had to do this by hand.
It's kind of confusing.
I had to when I took stats.
When you change it, when you gotta
I'm
treat
glad they
this
changed the
as
rules
it.
by the time I got it.
So these are sweet.
There's your line. For X being dependent. Wow.
Mm.
Again, this was if we were actually doing the formula, not plotting it to get the line. We could just do that and it would just give us the equation of the line. But I purposely wanted to show off what's going on in the background. We're just doing in the background. So come back over to here.
Oh, we still got something to do.
Yeah, I was about to say that's because it goes on.
X independent. Slope. Intercept. R times standard deviation of the dependent over standard deviation of the independent. Intercept, average of the dependent minus slope times average of the independent.
So would it be 0.54 or would it be just 0.5?
I'm just going to use 0.5. I'm just going to keep it to one decimal place here, 0.6 and 0.5. I'm just going to go one decimal point more than what they gave. And all the data has no decimal points, so I'll keep it to one.
Now we need to find the Y dependent and X dependent.
No, we already did all that.
Oh.
They're all right here.
Oh, okay.
We don't have to do it again because we already found all that information. It's just a matter of now using the proper order. See, so you were all worried, oh my God, there's more to do. No,
Yeah, we
it's
just
just
got,
flipping the order.
it's gonna take a little while to understand. I think that this one we need a slope is.
Be that regression line.
If you got a computer, you know how to which ones to keep going back to.
So you're gonna post this, right?
That's what we posted.
Yeah.
I may even be convinced to post the Excel file itself as well.
Yeah, that would be nice. Because
Because I don't got many tabs yet.
You know the project's due tonight, right?
Oh, tonight? I thought it was on the 6th.
tonight, 11:59.
Oh, what the? Oh, I thought it was the 6th.
Now that I have more time, I'm gonna do it.
Wow, nothing like waiting till the last minute, huh?
Wait.
I just wrote a 10-page essay.
Oh, by the way, you have another problem you got next week.
That's
Essay?
huh?
Yes.
Right? Sorry about that second project.
That's the project is due tonight. I thought it was due.
First project's due tonight.
What the? Oh my God. I don't know why I thought it was 6.
So let's do something I haven't done yet.
Yeah. Yes.
Let's actually take a break.
Please.
Yes. I was just telling you.
I'm back at 8 o'clock.
Sometimes we need a little bit, 10 minutes break. 30 French.
Oh my God.
Because this is all we're doing tonight is regression. If you do that, you may have a very angry wife.
We got a
Actually, I did give a break, didn't I? I gave a break last week for the test.
Yes. You know about it, right? You made it peanuts and those sugar.
I'm in a good mood because the Astros got eliminated.
I tried to check up on like it was probably for this project.
As long as the Astros got eliminated, I'm not happy with the Mets are.
Russian.
So if you-
And, oh my God, the Orioles.
Somebody else don't tell you.
Their drought of
I don't know
winless in the
why I
postseason
was
continues.
I did last
Total
week.
runs in 2
I had
games.
the day off today. I was working 7-day streak.
Brewers are about
Is it
to
alive?
Yeah.
Go along with the videos. That's exactly what I did. Everything that she did.
I have it still in
the
the
last like
Yeah.
4 questions. The last 4
I
questions.
want, so, remember the last 2 years when the Braves lost and they said, oh, it's because we had the catcher? So I said, I was telling my friend, watch, the Braves are gonna lose and they're gonna blame the fact that they had to play a doubleheader. And what happens when I'm reading the post they're blaming the
It's
doubleheader.
something I think all you know is watch the
I
video.
saw something.
And
I
follow the
did
videos. I did it like
the Braves,
11
they
o'clock at
complained
night.
about the day.
What time
Complaining
show
about
was
the-
We had to play doubleheader.
Like an hour. Oh, okay.
All the people are injured.
But it just go back and forth with hers. I just had to keep going back because
So if we,
how she was doing it for
if we-
many
if we
times.
do look at this project like,
looked like that.
12
I asked
o'clock.
a question. I don't know why.
Did you download it on your
it still count though, right?
Yeah.
That's why, because hers, she did it
Was on the web.
on the website.
Yeah, but it was like I had to figure out how to make mine look like hers. Only
I really didn't know about the
same, but
project.
it wasn't hard.
Wait, so Professor, is he today? 11:59?
Yes.
Yeah, you know how you
You
do
was doing
it,
right
right?
after class.
I don't know how to do it.
Just look at her video. That's it.
So you did
It does look easy.
I did it.
It does look really easy to do. It's
It
just,
was easy. All you had to
long.
do is 5 years.
If you watch the video,
If you watch her, I was going back and forth like.
I don't know
well,
why.
you don't have to watch a video. She gives the instructions.
Yeah,
But
just
it's
put
easier
the
to
video.
watch
put
the
a number.
video.
I'm gonna watch the video in there. I got the instructions there.
Yeah, because she went back to the instructions in her video and it showed you in the video how to do it.
You want to add, like, you want to make sure you're lucky enough to work on it.
When I found out I was teaching stat, I was so excited.
Not if it's
So many good
My
ideas
baby
for
said it
podcasts.
only gave me 14 days.
Hmm?
Not only said it only gave me 14 days. I can't carry it.
I don't even know how many.
It only gave me a 14-day thing.
It didn't even give me a record. I didn't see
Yeah,
anything about
I
it.
get it showed me
You
my
got cash up.
14. I don't know if she was
And regression's gonna, the next project is on regression, I guarantee you're gonna use it.
And it's due to 16
Why do
days.
they wanna use a program that you have to spend $1,000 for?
Wait, so what about when you got the mini? You got mini? You use yours on many times?
Yeah, but my 14, my trial
I
was
know.
14 days.
That's why I was not able to number it at all.
But I didn't do mine until I think I
See,
didn't do it
they are not numbered.
like yesterday or the day before yesterday. I had just started.
No, but if you sign through public school, I think it's.
You want to touch on it?
Yeah.
Sit down with it.
Just make
So
sure
it
you
didn't
don't
make me try it.
just
I
make sure you
tried
don't spot
the-
anything on it.
The mini kind of thing, like, just available to open.
Because I do it off of the.
I don't know.
I downloaded.
Yeah, I tried so hard.
See, cause that's what I'm thinking.
Figure
Schools
that
don't
out,
use
but-
Minitab. They should
They
use
should
Minitab
be
to like,
I think they do.
but that's not,
You never want to.
I didn't come
But
to
I
that.
can't,
Like,
she said you have to use
I can't see anything about.
and if, once it expires, you're gonna have to use the,
yeah. I don't know too. I'm gonna see if I can do another one with different email. Like if I delete
I
it
doubt-
from my computer.
I don't think you can. Cause I was looking on there and you have to use a school or organization email.
I didn't use the school email for mine.
I did.
I did.
Try
I
using,
made an email account.
try signing in with your school email, because apparently the school made accounts for everyone.
Yeah, that's not
They
bad,
did.
yeah.
So wait, yours is free.
Which means maybe the school is now giving away a license and that was all written before, which is possible.
So I just used the email. Maybe that's why I got.
Try signing in with the school email and see if,
Because when is the second project due? The 16th, right?
no, the second project will go live next week. And I'll give you 2 weeks.
Ooh,
So I think I've set the 23rd.
I had no idea. I thought it was too late.
I'm gonna just do it as soon as possible while I still got my free time.
I
I
did
would
it
just
that
knock
way.
it out quick.
Yeah, I do. It's gonna be okay.
And not worry about the third.
Yeah, I like to give 2 weeks for projects.
But sometimes we struggle. I got to.
Actually, I would really like to give a month. Right, sign the project, write the start of what the project covers, and give you an entire month of work on it as we cover it.
No,
No, everybody has.
That's what, get the grad school, give you the field project, they sign day 1, and they go, see you the last day, that's when it's finished. And they're back to class.
So here is.
So I had, when I took my advanced lab in physics, it was split into 2 parts. You had 2 different research projects, and that's literally what the class was. The first day you went in, they went over what you're doing. Here's your project.
So the whole.
See you when it's due to give a presentation.
That's not bad. So the whole project too is on reversing.
Does it take that long to complete though? Oh wow.
Oh yeah, it took that long.
That's all.
I was an English class teacher.
Say the next one for the 16.
They're always
That's what the cell says.
So are you like a mathematician?
Basically,
Because he said, I know.
I would say I'm more of a mathematical physicist. I was not. So when I did my degree in physics, I concentrated on theoretical physics, not the experimental, which means advanced lab was my least favorite class. So it wasn't an experimental. I was
Yeah,
which requires a lot of math.
yeah. Certified
The
title.
reason I got a math degree is because I was also an astronomy, theoretical astronomy.
you was trying to work with NASA.
I know the guy who was teaching the last class I needed. I was actually friends with him.
All I had to do was click around.
And he came up to me
First chart.
2 weeks before the, so it was supposed to be offered in the spring. 2 weeks before the end of the fall semester, he comes up to me and goes,
So this is fine. Yeah, this is
I go, what the fuck did you do?
on top. So that is
He goes, I accepted an administration position, and they're not letting me teach. So that class I needed was canceled. To be offered the next fall when they found a replacement.
And you was
I was supposed to graduate this spring with my physics degree and astronomy minor.
That's myself.
That was, and I needed that class as a requirement.
That is.
And that was your friend too, so it's even crazier. But that's not his fault though.
That's still your friend.
Yeah,
It wasn't his. It wasn't his.
and I said, I looked at him and I
this
said,
is mine.
Both of these are 5.
No, this is 5. This is 6. That's how.
better
it's
hope you don't run
like.
into me in a dark alley.
I know that one was
That's okay.
And then what did the motherfuckers do?
Yeah,
The
now.
very next year, they like,
It's crazy.
What else do we have to do?
so I had to go an entire extra year because of that one class. I'm like, what can I pick up? Math, perfect. So that's why I got my full major, because of that.
Literally just because of that.
Because I'm like, I'm not graduating without my astronomy minor. That's what I went for. I didn't want a physics degree, I wanted an astronomy degree. But not a lot of schools offer astronomy degrees. You have to do physics major with astronomy minor to get the astronomy.
See, I found all that interesting. I found physics and astronomy all interesting. What I hate about it, the math, which is that's I know.
Oh, that's the
yeah.
I understand the physics. I understand the theory,
Mhm.
which is opposite of a lot of people. I actually understand the theory. It's the math that I don't like doing.
Exactly. I feel like I'm the same way.
Whereas everyone else is opposite. They can get through the math, it's the theory that they have a hard time understanding, whereas I understand the theory.
If you can get a little off, that would be good.
Even when you told me, I remember I was talking to my friend about it when you said about the dimensions thing, and my friend was like, she was like, well, how do you know? How can you prove it? I'm like, you can't prove it, but I feel like the theory behind it.
And that will never be proven. Because so the essence of string theory is everything's made
No,
of strings.
yes, man, that's the stuff.
So not the standard particles that you see, but those particles themselves are made of different orientations of strings. Well, the strings are the Planck length, which is the smallest length in the universe. In order to magnify large enough to be able to see a string, you need the Planck energy, which is essentially the total energy in the universe. Which means we're never going to be able to actually be able to magnify to see the strings. It will always just be philosophical. We will never be able to verify the strings. However, they did verify a particle that string theory predicted. They found a particle of that energy. This was back in 2016, I think it was. They call it the God particle.
The guy I heard of it.
Because it's the particle that gives everything mass. And that was predicted by string theory. So the fact that they found a particle of that energy gives huge credence to string theory. That was a massive breakthrough. We were having a party. I actually think me and my friend, when that came out, went out and got drunk to celebrate.
That's good though.
To celebrate the finding of that particle.
Yeah, that's crazy.
We were so hyped. launch the James Webb Space Telescope. Because I actually wanted to work for NASA. I wanted to work on that project.
This box spot is,
And then I realized how much of a bitch physics grad school is. And I was like, let's do math. That's okay.
And this is easy.
Yeah, so I want
This is the easy part. This is the easy part. It's only the formulas. I like the theory. I can understand. The math, I can't. But
Can we get 2 extra points for every round the Phillies get through?
I mean, we can, but then if the Phillies don't win the World Series, we're going to take 100 points away from them.
I won't even be here if that happens, so. I'm taking this.
I actually had a teacher one semester give us extra credit. It was 2008.
this is 8, right?
Wager points on who wins the World Series. So it was extra credit because you could lose points if you win. One person in the class said the Rays, everyone else said the Phillies. Guess who got busted on the night the Phillies won the World Series? And we're back. Table below shows heights to the nearest inch and weights to the nearest pound of a sample of 12 male students drawn at random from the first-year students at State College. Create a scatter plot with the least squares regression line. So again, I will do this both with Minitab and Excel. First Minitab. I entered the data. How are we going to do it? Who remembers what we have to do? There are two ways. Let's say we want the equation.
I'm not doing it on Excel.
Oh, good, then you're able to come up and present it. Huh? Yeah, how do you do it?
Little graph.
Basically, go over where it says graph and then scatter plot, right?
Yes, that plot.
Always right.
And then
Yeah, and then you push OK, right?
That's not going to give us the line.
I know.
We want the line.
I know. I'm kind of getting.
Yes.
I mean, you get the
Survey.
line.
Is that going to give you the equation?
No, but
Regression.
we'll get there.
Regression analysis. Let's try.
What is it?
Regression analysis.
Under where?
Chat. This not this is statistics.
That?
Good regression.
Regression?
Yeah, regression, and then yes.
What is our response variable?
Response variable. This the width.
They wanted weight yet. It's actually giving me solid. I don't think it does. That is not, this one you're talking about, that's not R squared. I don't think it is. I would say that is not strong linear correlation. And so I look at this and I go, yeah, there's not really strong evidence of a linear correlation between height and weight.
Why you say so? What is the
And look how far away all the data points are from the line.
which line? The horizontal line that is there.
The red line.
Oh, somewhere it's
And they're kind of
close.
really spread out from it.
Okay.
So this really wouldn't be a good correlation.
So when it's close, that's when you know that it has.
The closer they are to the line, the better. So I'd say this probably has a weak R. This has a pretty small R.
I have a question. Do you control the temperature in
No.
I know, right? It's freezing here.
Really? I'm hot.
It's right behind you. Something behind you like that.
Yeah, they put this in. It's like in the hospitals. They put them in there, but you don't actually have any control over them. That's controlled by administration. You can adjust it all you want. It's not going to do a damn thing.
No.
Come on, you don't pay them enough money to keep the place cool. You barely pay them enough money to pay me.
I'm gonna pay when we start making money. I'm gonna have to get a lot of money.
So sheet 3, let's copy.
This is Excel now?
There's our data. Of course, again, we have to do this because the way screen sharing works is weird. Okay, you said you did it in Excel.
No, I said I was waiting for you to do it in Excel. That's what I meant to say. So,
Where do I go?
where do you go?
I started for you. I got you on the right tab at least.
Same page.
You're good at something else. You're good at chat.
Insert.
Insert. Chat.
I would not use that. Just use the scatter plot and then add the trend line at the end. Now, notice how it didn't put anything up there. Right click on the chart, select data. I think if I do this, select data range at the very top, and then highlight.
Also, the entire, yeah.
Now that actually looks better. Insert, or not insert, sorry, chart design, add chart element, trend line, linear. Double click the line, display equation. That there. We also want to add the axes, right?
And this is for the next project, right?
I'm pretty sure. I haven't actually looked at the next
Should
project.
be. You know that stuff.
Yeah, it's a project 2 right after progression.
Right.
So there we go. Now, why does that look so different? Push the wrong button. Ignore that. Why does that look so different from that?
That's a regression analysis.
Same thing.
Aren't the numbers different?
No, it's the same data.
No, I'm saying the axis numbers are
Are they?
That is
Yeah,
fit-
they look
that-
like-
That's a fitted line plot and that's a scattered line.
The access numbers are the same. It is
What?
something to do with it.
But
It's a scattered plot.
They're both scatter plots.
I'm saying how the numbers are spread out.
What is it? The origin is not actually at the origin in many tab, which Excel it is. But all the numbers themselves are the same.
No, I mean different, like they not, just how that zero.
It doesn't cross at 0, 0. I can adjust that if I really wanted to. So double click on the horizontal. See where it says here minimum and maximum.
That's zero.
So what I did was I set the minimum to be 60 and the maximum to be 74. And I just let the units be major, that's just how much is going to change.
Okay.
Now if you double click on the vertical, same thing. I set the minimum to be 132 and the maximum is 177. No, I did 178. I must have. Yeah.
Yeah, I think this give you a better foot.
Or did I do
This give
180? There we go.
you
That looks like what it
better
is.
understanding.
Which just gives you a more zoomed in look, but again, that could be misleading.
Yeah.
But that kind of more now matches
What it looks like on the.
with what's in
Yeah.
that page. So, but now that was a case where it didn't start there, right? You saw all the data. It's still, you could still say maybe there was a linear correlation. You can now go away. So the table shows in inches respective heights of a sample of 12 fathers and their oldest son. So we're going to create a scatter plot with the least squares regression line and construct a table giving the fitted values and residuals. So for this, I'm just going to use Excel. There's our data. Insert, scatter, select data. Okay. So let's add the axis titles and the trend line. Let's get the equation. Just move that up somewhere. There we go. That looks pretty good. So what I'm going to do is move this out of the way. So let's move that just like down here. What you can also do, chart design, move chart. And then you can create a new sheet for the chart. This is sheet 4, so I'm just going to call this chart 4.1. You can also do that. So you can keep your charts and your data separate.
I can't get to the lines.
What do you mean you can't get to the line?
So every time I put the data in, it won't let me get to the line. I try to go the way you try to go about it. I don't have that option.
To add a trend line?
Yes. So I can get the equation.
See me have to play.
All right. Thank you.
So this is where the formula is going to come in handy, the line. Fitted value. Right, so remember, we have to make a chart of the fitted values and the residuals. So the fitted value is the predicted value based on the trend line. Y hat equals this. They actually gave us the equation right, on the chart. 0.4764 times x plus 35.825. So this is what it's predicting using the least squares line. So they predict that the height of the sun for this father would be 66.791 inches. Scroll that down. What was the residual? So it's the definition of residual. So how do you find it? Y minus what?
Y minus Y. I say absolute. What is the Y?
Actual minus predicted. Those are your residuals. didn't ask for it, but I'm going to do it anyway. Let's do a residual plot. So, select data. I am going to remove that. I'm going to add. So the x values. Are the same, right? It's the explanatory. Why are you doing series name? That's better. I can always delete that. And the y values are the residuals. But I don't like where this is located. So I don't actually like that it's crossing there. So if I double click it, see down here, it says vertical axis crosses. I'm going to change from automatic to an axis value. And actually, no, I think I will keep that as automatic because that one I don't want to change. It is the vertical I want to change. Change that to -3. That looks better.
Yes, because I was wondering why that was in the middle of them.
So instead of having it cross at 0 on the vertical, I'm having it cross at -3, just to make it look without the interruption of that axis. So there's the residual. So again, chart title, let me add that back in. And that's the residual plot for the height of son versus height of father. Let's label the axes. What is the horizontal axis representing?
Son, height of the sun.
What was it? I'm old and deaf. Speak louder. And what does the vertical represent?
Height of the sun.
The residual. Right, you plot the residual against the explanatory in a residual plot. And again, let's just move this. Let's call that chart 4.2. What was the rule about the residual plot? And when you can assume linear correlation?
Does it have to be between 0 and 1?
residual plot.
Is that the one you said it was between 2 and -2?
Those I think have to do with the extreme values.
Pattern.
What about pattern?
There's no noticeable pattern.
If there's no discernible pattern in the residual plot, then there might be linear correlation. If there is a pattern, there is no linear correlation. Is there a discernible pattern?
No.
No. So we'd be safe in using a linear correlation. Again, this doesn't mean that there is. There might not be a linear correlation. It's just, at least we can safely use one. Calculate coefficient of correlation and the coefficient of determination. Might. Just see something. No, it won't give it to me. Of course not. Darn. So I'm going to use the same chart because we're using the same data. I'm going to learn how to spell. Sun, I'm going to use that as the Y. So we want the correlation coefficient, which means we need x times y, x squared, y squared, and then all the sums. Thank you for that. So that's A2 times B2, right? X times y. This is A2 squared. That one is B2 squared. Drag and drop. Sum A2 to A13, that gives sum of x. Flip that over. Sum of G2 to G13 gives the sum of xy. Oops, why did you do that? Let's call this correlation. What was the formula for correlation coefficient? That's that. So if you're so upset, you're throwing pens. Numerator, sum of xy minus sum of x times sum of y over n. How many data points do we have? 12, they told us in the problem. That was sample of 12. Divided by the numerator square root. Sum of x squared minus sum of x squared over 12 times sum of y squared minus sum of y squared over n. There is the correlation coefficient. So, what does that tell you?
R.
Right, so what does that value of R tell you? What can you say about the data?
It is negative linear.
So an R value of 0.7 is a fairly strong linear correlation. And it's a fairly strong positive linear correlation. 0.7 is pretty close to 1. You have to remember this axis isn't at the origin. Now we need coefficient of determination. Which is what?
R squared. Bless you.
Oh, I was trying to get that back. Oof. Oof. What does that tell us?
It's a long number.
It went down in correlation.
So what does the determination tell us?
The variations.
Yeah. In other words, that's probably going to predict about 50% of the values. It's good enough for government work. Wish government got 50% of their stuff right. That'd be nice. So I think there is a way to find correlation in the tab. I have to remember how I did it. Regression. I think it's either regression. No. How did I do it? Calc. Oh, yeah. That's right. I did the calculator. Remember, Minitab has a calculator as well. So you could have done the same thing in Minitab as we did in Excel. Oh no, never mind. Basic statistics correlation. Right down there. 0.703. So you don't have to worry about that nasty formula if you use Minitab.
So Minitab is better than Excel.
In that case, because Excel doesn't have an option to find the correlation, I checked. I'm sure it does, you have to do an add-on. Where am I? Here. So does higher cost of tuition translate into higher paying jobs? Table lists the top 10 colleges based on mid-career salary and the associated yearly tuition costs. So this should be near and dear to everyone's heart. Does paying more for college correlate with an increase in salary? Let's find out.
Yeah, those numbers look all right.
Just remember that tuition yearly.
Yeah,
How
I
many
know.
years you go to school?
As soon as I said that, I thought about that too.
How many years you go to school? So $57,000 a year. You're making 137.
All right, so here we go. I have it set up now, Minitab. What was that you threw? Calculator? Your phone? Your portable charger. So upset by this that she no longer charged it. So stat, basic statistics. Let's do correlation. Delete those variables. We want to do the salary against yearly tuition. So I think I want that against that. Let's see if that was the right order. It was not.
Yeah, I would look right.
So with 10, that didn't happen. X, Y. That looks better. So before I even look at the correlation coefficient, look at that scatter plot. Is there a linear correlation? No. There is no way that's right. Mid-career salary is Y, yes. That is not what I got on Excel. Unless I just did something wrong, which I guess is possible. But I got a really small number. 1.6 times 10 to the minus 7. Which makes more sense than this. Because that is close enough to 0, I can say there's no linear correlation. Whereas here, it's 0.142, which is not that close to 0. So I don't know what the hell it's doing.
So let me ask you a question. So if it's 0.5, you would consider that
That's
close.
that's half, yeah.
Yeah. So if it's 0.4 though, you would still
Still.
consider it's too high.
There's still good evidence, yeah. That just, I don't know where to get that from. That should have been career salary. It shouldn't matter if I do Y versus X, it should be the exact same. So G12 minus X12, E12 all over 10 divided by the square root of H12, which is the squares, minus F12 square root of 10 times Y squared minus, so unless these are wrong. No, it was all right. Yeah, so I don't know what's going on. That makes way more sense to me than what many times given. Whatever. The answer is no, there's no correlation. So go to a cheap school. Another way to think of it, when was the last time you had a doctor's appointment? Did you go in and before the doctor started exams, hold up! Where'd you get your degree? No, right?
It's usually plastered on the wall though.
Not in the doctor's office. Maybe in his actual office, but not in the examination room. Okay. Or actually, maybe. You have a plumber come over and go, hold up! Where were you trained? Maybe you should, actually. That one you might want to ask. Like, maybe the only time I'd ask a doctor where he got his degree is if it's, like, a specialized thing. Like, I have cancer. I'm going to die in a week unless I get the best treatment. Then I might go, where the hell did you get your degree? Are you the best? Otherwise, I'm just going in for a physical. I'm not really asking where they got a degree, right?
You know what, I think about that now, but now that you suggest that, I'm going to start thinking about that.
So, don't go $400,000 in debt to get a degree in German polka history and make $30,000 a year. That's not good ROI. Just food for thought. Questions on regression? Project 1 is due tonight. You also have the 4th quiz, which will be due next.